Hi all, this is a very small lecture video on the topic information, how we can mathematically model information and how we can calculate the information contained in a message or a signal. So first of all, we can define information as the amount of intelligence that is contained in a message or a signal, the amount of intelligence that is conveyed by a message or a signal. So in order to calculate the information contained in a signal or a message, we have to model or consider this message or a signal as an event, and then you are relating the probability of occurrence of this event to the information. Okay, so information content in a message, it is related to probability with an inverse relationship. That is, if the probability of occurrence of an event is more, then the information you get when that event occurs will be very less. And vice versa, if the probability of occurrence of an event is less, then when that event happens, you will get more information from the event. That's how you relate information and probability. So this is how we relate information and probability. That is, information is inversely related to probability. And your I here, that is the information what you get when an event occurs or when a signal is conveyed, is what you call it as self-information. Okay, so again, now we have a relationship between I and your P, that is your self-information and probability. Now we need to find out how you equate your information and probability. So in order to find that relationship, you can consider a communication system, what we are dealing with. That is, you're considering a communication system and it is considered to be transmitting some messages like M1, M2, etc. with probabilities P1, P2, etc. That is, each message M is considered to have a probability P. Then what we have discussed now is that the amount of information conveyed by a message MK, you can write it as IK. Okay, and we have the relationship that your IK is inversely proportional to your probability of the message. Okay, so IK is inversely proportional to your PK, and we can remove this proportionality by equating your message as a function of what? 1 by P. That is, from this relationship, your IK is directly proportional to what? 1 by PK. And when you remove the proportionality, you can write your I is equal to some function of 1 by P. Okay. Now we need to find out what is this function that relates your I and P. Okay. So for that, again, you can consider two events with probabilities P1 and P2, where P1 is conveying a self-information I1 and P2 is conveying a self-information I2. Now, the total information what you get from these two messages or these two events can be written as I1 plus I2, as we already know that I1 is related, or your I is related to P as what? A function of 1 by P. You can write this as f of 1 by P1 plus f of 1 by P2. Now, let's consider these two events occur simultaneously. So when two events occur simultaneously, the probability of occurrence of that events can be written as P1 into P2. The joint probability P1 into P2. Now, when it comes to the information conveyed by these two events together, your I12, that is equal to what? F of 1 by P12. Okay, that is f of 1 by P12, where we know P12 is P1 into P2. 1 by P1 into 1 by P2. Now again, we are just splitting this 1 by P1 into P2 by f of 1 by P1 into 1 by P2. Now again, we have this equation 1 where you get the total information as f of 1 by P1 plus f of 1 by P2, and another equation where you get this total information as f of 1 by P1 into 1 by P2. Now let's equate this two equations 1 and 2 where you get a function which describes a relationship like f of 1 by P1 plus f of 1 by P2 is equal to f of 1 by P1 into 1 by P2. So obviously this function that satisfies this relationship is nothing but a logarithmic function. So you can write your I is equal to That is, when you remove this proportionality, you can write I is equal to a function of 1 by p, where this function, what you have found out, is a logarithmic function. So your I is equal to what? Log 1 by p. And in digital communication or your binary communication, we always have this log with a unit with a base 2. So when the base of this log is 2, your unit of information is bits. And when you have other units like natural log, it is nats, and for log 10, the unit of information is decits. So finally, we can put in a box a very important relationship between your I and P, that is your IK for conveyed by a message MK is equal to log to the base 2 1 by PK, where 2 comes to play when you're considering a digital communication. And if you have your log, if you want to find out in your calculator, you can write it as 3.32 log to the base 10 1 by P. So, if you're really happy with my lecture video, please do not forget to subscribe my channel. Thank you.